I'm CK. The other day I did a looping envelope generator from AI Synthesis, and I bought two things from them. So tonight we're going to do the other thing I bought from them, which is a Quad VCA Mixer. So we'll see what's in here. Looks like it might be fun. Hope you enjoy the video. Here's the packaging. AI Synthesis out of Portland. AI007. So based on my limited knowledge of their numbering system, this is the 7th product they've made. And we'll see what's inside. I haven't looked at their website. The last time on the looping envelope generator, they had their own build video. They very well could for this one too, but I like to do my own. I am so bad at opening packages. Okay. Bubble wrap, ick. Hate bubble wrap. Let's see what we've got here. Let's take the front panel out first. Gives us an idea of what we're going to be doing. Aluminum. VCA mixer. Mix level. Probably knobs. RSP 1 through 3 or 4. CV 1 through 4, in 1 through 4, and then I assume that's the outputs and the final mix. And they're another one of the companies, and I bought this directly from them. I did not go through a third party for this, that bags every single component in its own little Ziploc bag, which I am not a big fan of. Potentiometer. All the jacks with all the ground pins poking through the plastic. But, as you may notice, they took the panel nuts off for us, which is good. Saves me a couple of minutes. Chip and socket. That's the TL072, that's an op amp. Tall trimmers. Power cable. Now let's look at the circuit board. Oh, there's two circuit boards. So here's the knob and jack panel. The ground pin hole is a little offset. So here's the ground pin, and it's not straight above the other two legs like everything else is. So that's a little unusual. I'm looking at their build guide now, and they've got a lot of good pictures. But yeah, he chose to offset the ground pin, I guess, to get the LED in the right place to be visible through that hole. Okay. Oh, before I pull more stuff out of the bag, let's take a closer look at the boards themselves. They are good crisp silk screening. The values for all the components are silk screened on the board too, so theoretically you don't need a build guide. And this is nice. AISynthesis.com, a 1007 VCA mixer. This machine kills fascists. Well, I don't particularly want to kill anybody. Making fascists not fascist is a good thing. And here's the backboard. Now, one thing the clever observer will note here is this backboard is all surface mount. So If you're a beginner, don't even think about it. This would be a bad place to learn how to do surface mount. So I would recommend that if only attempt this board and this machine if you're comfortable with hand surface mount, or if you have a surface mount oven in your workshop or whatever. I don't. So there will be a lot of chips and resistors and capacitors going on the board. Diodes are through hole, which is interesting. So that's the board. If we look at the through hole, they're all plated all the way through, which is good. Always good to have fully plated. Lots of test points on here. Also, he is very liberal with space. His traces are very narrow. I'm looking at it up against the light. Let me see if I can do that. I don't know if that's going to be completely horrible or not. But you can see the traces are all very, very thin. Not good or bad, just interesting. Let's see what else is in the bag. A card and a sticker. I already got a sticker of theirs. It's on my sticker wall. And resistors, each value in its own bag. Again, everybody go look at the way Division 6 ships their parts. Do it like they do it. Don't do it this way. Here's all the SMD stuff. A bunch of caps, resistors, ICs, surface mount also, and all the knobs, and these are okay knobs, not great knobs, because they've got metal set screws going into plastic, not even into a brass insert. Now the large rotary knob does have a metallic plate that the brass set screw goes into, but these others, you just have to be really careful with them when you install them so you don't accidentally strip the plastic. Headers, pin headers, power supply, some more caps, LEDs, screws, caps. So let me get the soldering iron and heat it up, and we'll dive into this. So we're going to start with the surface mount components. For surface mount, I use MGD 0.025 inch, very thin solder. It has flux in the center. I'll show you how I do this, and the author of the kit uses the same technique I do, or at least in words. They do have a build video on YouTube. I have not looked at it. So what we're going to do is we're going to take a little piece, we're going to take a piece of solder, and we're going to put a little bit of solder on one pad, on the outside pad. Now we're going to get our handy dandy tweezers and pick up the chip. Make sure that the dot is over yonder. Now pick up the chip. Try and pick up the chip. Move it over onto the pads. Get it aligned so it's enough contact with the pads and they're all straight. Heat that pin up where I put that little dab of solder. Let it cool. Let go. And the chips, if you bend it, it'll move. But basically, the chip won't move. And now you can confidently solder the other things. The other thing I want to point out, you may have noticed this in other videos, I use a .03 soldering tip with a 30-degree bend, and I find that really good for surface mount for me. You may have a tip you like much better, and when you're starting out with surface mount, I recommend you experiment to get the best you can. And if you look on Amazon, there are kits from a company called Gikfun out of China, specifically designed to help you learn how to do surface mount by hand. So here's what we'll do. I put the soldering iron between the legs, get that leg. Now I move to the next one, get that leg. Try not to bridge, and I didn't. To this one. To this one. Next one. And one thing that will happen as you solder, you pick up a little solder on the tip of your iron. Be sure to periodically clean your tip, or else it will bridge for you. See how easy this is going in? I mean, it's just like a through hole, really, if you're just careful and methodical. Now that whole side is done. Oh, I do want to point out that when I did this, I locked that leg down and soldered the other side. Because the first time I did this, I actually locked one leg down and then started soldering next to it on the same side, and of course that solder came loose. The chip slid. It was agony. So tack down on one side, do the initial soldering row on the other side. So that's it. As you can see, and I'm just double checking, everything is soldered well. Good flow onto the underlying pad and no bridging. So that's surface mount soldering in IC. As I said, I'm going to turn the cameras off and do the other one, the other 5. That went pretty quickly. I put the other 5 ICs on the board, took 15 minutes. Surface mount's not scary. After you've done it a couple of times, again, you'll develop techniques. Oh, one interesting thing, pin 1 on these 2 chips is here. Pin 1 on the other 4 is here, upside down. I don't know why he did that either. It probably has something to do with trace layout. Now we're going to do their 8 5.1K resistors, and I'll do one of those. I'm going to drop them into this parts bin. And this is the trickiest part of the whole thing. So the resistors are in there, and we've got to peel this plastic film off, and we don't want resistors to escape the parts tray, because you will never ever find them. So we drop them in the bin like so. Make sure they're all there. Make sure nothing's stuck to the plastic film. These do not have their values listed, and unfortunately all he does is provide arrows in his build guide. He should probably put the R numbers there too in the actual text of the line. If I look at the bill of materials, let me look at that. Okay. In the bill of materials, the R numbers for the location of the resistors exist. So we're going to do a 5.7 at R8 and R9, and putting resistors on is very similar to putting the ICs on. We'll put a little glob of solder. That's a little too much. Little glob of solder on one pad of each. Now we'll get our parts bin and tweezers. I use very sharp-nosed tweezers for these components. A good set of tweezers is a must for your electronics workshop. I've got a video on my channel about tweezers and what to get. So you just put it over there, heat the solder up, and she drops in, just like the IC. And then same thing, tack the other side. Be careful not to push on the resistor while you're doing this, because with the heat transfer you may actually lift the resistor up. But that's it. And again, very simple to do. One other thing, and I'm going to put this back while I'm talking so I don't squeeze it and have it go away. I've demonstrated this technique in the past, and some folks have asked why I don't just put solder on both pads. I tried that, and what that does is it makes the positioning unstable, because right now I've got that one solder ball that I'm going to push this resistor down onto, and the other side is flat, so it doesn't interfere. If I had a solder ball on both, the resistor rocks. One thing you'll note as I do this is sometimes the resistors and the capacitors will not be quite square on the board, and I don't try and fix that because it doesn't matter. There's plenty of space on this board in particular, and I've got conductivity through the whole thing, so I'm not concerned about them being cocked a little bit one way or another. I'm not going to try and chase perfection on that. The other thing, you have to be very, very careful when you're working with surface mount, and it's not true on this board, but it's often true that components are very close together, and if you get your soldering iron near an already installed component, you can actually move it off its pad if you're not careful, if you haven't watched, which with through-hole you can't do. All the SMD components are done. I went ahead and did all the capacitors, also because same procedure as with the resistors, so there was nothing particular to show. Now what I am going to do is I'm going to take this little piece of paper and I'm going to go slowly down all the rows and check each connection to, number one, make sure I actually soldered it, and number two, to make sure it looks good enough to provide good conductivity. And I use a piece of paper to do this so I can focus on just a few of the components instead of having my senses being overwhelmed by seeing everything. I find it very handy. There were 8 surface mount resistors on the knob board, and unfortunately the picture he uses with the little arrows to show you where that is, first off, it's cut off here so you don't see this side, and secondly, he took the picture after he had installed the jacks and knobs, so it was really hard to see. So fortunately these are the only surface mount components on this board, so it's relatively easy to find them, but that picture needs to be fixed. So someone who's not as experienced or doesn't have quite the confidence to dive right in, doesn't get confused. So let's see, now that we're surface mount outed, we're going to do the regular old resistors. And there's a bunch of little bags of them too. Again, I'm not a big fan of, let's find them. I'm going to back the zoom on the camera out. Like this, I don't think we need a bag for individual resistors. I think that's very wasteful. Here's 3 bags. 4 bags, each with 1 resistor in them. You know, combine them and change the label. It's easy enough for people to figure out the value of resistors. I mean, surface mount capacitors, maybe, because you can't see from the package what the value is, but resistors, you can figure out pretty easily. So since it's resistor time now, normal resistor time, I'm going to go ahead and go back. Oh, one other thing I wanted to point out. It's just interesting. As I mentioned, the resistors do not have their values silk-screened on the board. The capacitors, on the other hand, do. So I don't know why he chose to have the capacitor values on the board, but not the resistor values. Don't know. And now, again, since we're going to do all the resistors, there's nothing particular to learn about that. So I will once again go into fast motion and do that. Now I'm going to go back live here just for a second. Well, 2 seconds. First, these 100K resistors down near the jacks and area, he chose to make them stand up. I've talked about stand-up resistors in a number of videos. I consider them an unfortunate design decision. They are a short waiting to happen, they're a bridge waiting to happen, they're mechanical instability waiting to happen. And in this case, in my opinion, it's even more egregious because there's absolutely no reason for him to make these stand-ups. For all of these, there's plenty of space to drop them flat on the board. Perhaps this one, maybe, but these, this, even this can be laid down. There's plenty of physical space and there's plenty of tray space. So I don't know why he did that. The other thing I want to point out is for these 92K resistors, he's using the Dale ones, which are very, very tight tolerance. They're very accurate resistors. It's just interesting when you see somebody using them because they're a little bit more expensive. And of course, they have Dale printed on them and look like party crackers. And if you know what that means, you can, if you know what reference I'm making there, you can giggle with me. So yeah, I've just got 6 more resistors to do, so we'll just plug along with that. Speaking again about the surface mount for a bit, all the surface mount resistors and capacitors took about 40 minutes to solder on, and the same number of through-hole resistors would have taken longer. I don't know how much longer. I don't have an accurate gauge of that, but I know that they would have taken longer, mainly because once you get the swing of surface mount, there's less steps. You put a dab of solder down, place the part, put another dab of solder down, and you're done. Where, as you can see, with through-hole, you have to put them through the hole, bend the legs, then you'll solder them, and then you have to snip the leads off. There's 2 more steps for each resistor in through-hole than there is in surface mount. So even without being a machine, even for a human, it's more efficient to do surface mount. And again, once you get the hang of it, you can go pretty quickly. It's a rhythm like anything else. Like the rhythm of trying to find where this 4th 92K resistor goes. I remember there was one. These are 10Rs, right? Yeah, those are the 10Rs. It's got to be here. It's just hiding from me. There it is. So yeah, I'll have to, I can't tell, I don't know if he includes a schematic. I'd like to see why he chose to put the high tolerance resistors on there. Because again, they are pricier. And besides being pricier, you might notice the leads are a little thicker, which is why it was a little more difficult for me to push them through the holes. That also means that they take a little more heat from your soldering iron, because that thicker wire is conducting. It takes a little longer to heat up than the thinner wire, and it conducts a little bit more of the heat away. Just like a diode takes more heat, a little more time with the iron on the lead. So not a big deal, just remember, thicker the lead, the more time you're going to need to have your iron on the component lead and solder pad. And he uses a shrouded power connector, which I appreciate, because that means you're less likely to make a mistake. And it's got a little cutout here on the silk screen, which matches the cutout there. It also shows minus 12 volts there, so I'm going to just quadruple check it by making sure the red stripe is actually going on that side. I'm trying to pick up my solder. I should use the last of the 025. Let me do one pin. And that didn't go on very well because I was burning my finger. So we hold it down with our finger, heat that leg up again, get everything flat and parallel. Then we can get the other legs. Now here again, his picture, where are we on this? It's on the other board. We're going to put the LM4040C right here, and unfortunately, again, the picture that he has in the build guide has the potentiometers and all the other components installed all around it, and that's unfortunate for someone who may not be as comfortable putting things together. But I guess really, if as I say that, the reality is, if you're going to grab a kit that has 100 surface mount components in it, you're not going to be a beginner. So yeah, I can understand why it's less important to be as clear as potentially possible. Now again, you want to make sure you're not putting the C25 in the C10 or vice versa, because that would be bad. And even though the bag said C10, I'm going to double check the capacitor itself, I mean the transistor itself, and it does. I'm going to put the other regulator in at the same time. I don't know if he wants me to do that next, but I'm going to do it next anyway. And as you may notice, the flat spots are facing away from each other. And then we're going to go and do a bunch of caps, and I'm not going to do that this evening because the kitty cats want to get their food. They're waiting for me, so I'm going to shut her down for tonight and go feed the cats. Now it's capacitor time, and as usual with like resistors, we're just going to put these on the board without commentary because they're pretty straightforward. Nothing too unique about the caps in this kit. Just some disc caps, some square foil caps, and some electrolytic. I thought there were 2 more electrolytic, but whatever, we'll find them if they're around. Next, we put the op amp and the socket that holds it onto the board. Got a bunch of 4-pin headers coming up. 2, 4, 6, 8 male, 2, 4, 6, 8 female. So here's the pot board. I'm going to put all the male headers on the pot board and the female headers on the other board. Okay, all the little pin headers are pin-headed up. Now we're going to have to take the boards back apart because to put the pots and jacks on, we will need to have access to the back of the board, of course. And that will be the next step. Let's see, we've got some pots here. And here's the A pot. And these are the B pots, different taper to the windings for linearity versus log. and there's a whole bunch of jacks. So I'm gonna do the jacks and pots in fast replay, because well, first let's set them all in. Fortunately, and bless his heart, he did take all the panel nuts off the components, which I always appreciate, so I don't have to do it. So we'll set everybody in. Now again, remember, as I mentioned earlier, the ground pins on these bottom 1, 2, 3, 4, 5 jacks are slightly offset, so he can get the LED right next to him, and I can understand that. It's just a little bit of a pain to tweak them over, and I got a little solder in this hole. Let me clear it out. It's just a little pain to get them precisely aligned, because you're putting it in and twisting it a little bit. And there's all the pots down, and I'm going to tack one leg on this corner pot. I don't know why I didn't do that before I put the rest of them on, but primarily because I'm an idiot. Now we'll get the pots in place, and we'll be careful that we get the right ones in the right place. Okay, so that's all the componentry on the board, not soldered yet, just in place. Now we're going to drop the panel on. Hopefully it'll fit. The holes are a little rough. Oh yeah. All dandy. Now this one jack that I had put a little dab of solder on, I'm gonna screw that one down. And I'm going to do the same with this pot's support leg. So I've got two corners pinned down, and we can look at everything, make sure, oh, and put the, of course, put the panel nut on that. This panel's not, panel's okay, but it's not completely drilled 100% accurately. Okay, so that's the way it's going to go. So everything feels secure. So I'm going to go ahead and solder everything up, and that's going to, oh, let me drop the LEDs through, and then I'll solder everything up. And some people like just the tip of the LED coming through. I personally like the whole LED coming through, and that's primarily because in my main studio, my keyboard controller is here and my Euro rack is over to the side, so I often am looking at it kind of out of the, with a sideways view, so I want the LED out far enough that I can see them. So I'm going to go into fast motion and solder all these connections. After I finish soldering everything out, I put all the panel nuts on too, because you didn't need to see that. That's boring. Now we'll put the knobs on the potentiometers. And again, since these, well, this is a freaking Allen wrench. It's not a screw. This one's a screw, but these are Allen heads. Go get an Allen wrench to do that. Hold on. So again, when you're working with these knobs, This metal into plastic is easy to strip, so don't tighten it too much. So we'll turn all the pots counterclockwise, and now we get to the hardest part for me in any project, making sure the index lines on all the knobs line up, and I know I won't get it right. Now this one again has this metal plate in it which keeps it from stripping out, so I'm not worried about tightening that down, which is nice because that's going to be one that's used a lot. Okay, so they all turn well, nothing binding. Let me check my jacks. That all looks good. Now before I put the boards back together, I'm going to do my pass with a little piece of paper to make sure I haven't missed anything. And look at that, right there. I missed something. That's why I do that. And I use a piece of paper, so I'm only looking at one line of solder at a time, as I did with the surface mount slide. Oop, I didn't even get any of that pot. Gosh, I was going pretty quick, wasn't I? And on this board, since it's mainly surface mount, we already checked that side. Got those two diodes and the resistors and capacitors all look good. So now it's time for, well, actually I'm going to put the power cord in, like so. Now we'll do the final fit. Now you might notice there's no screws or anything else to hold the two boards together. They're being held together completely by friction in the pin headers. I may do something about that if I decide I want to use this a lot, but for right now I'll just leave it that way. So here's the front, here's the back, one side view, the other side view, top view, and bottom view. Now it's time to put it in the rack and see what she does. Now we're about ready to power it up. I haven't powered anything up yet. So here's where we've put the VCA mixer. So what we're going to be doing is we're going to use the Midi Thing to get CV for note and gate. The gate I'm stretching over here to my Patching Panda copycat multi, and it'll be splitting the gate to this ADSR and then back to this Bafaco ADSR. Same thing with, that's what's happening with Note CV is coming up to the copycat and feeding into this Duskwork oscillator, and this even VCO oscillator. This is from Bafaco, this is from Duskwork, as it says. And then the ADSRs are looping ADSR from AI Synthesis. I've done a build video on that, and that one, I think I already said that. So we'll turn it on and see how she works. First, we'll see if she blows up when I turn it on. That's always the fun part. Nope, nothing blew up. And you can hear we got a little bit of oscillation going on. I'm not quite sure what that's about, but it went away, so it doesn't matter. So now we've got two oscillators. That's the basics. So you can mix them any way you want. Now, that's a mixer, and that's pretty basic. So let's zoom back in on this thing. Now what's more interesting is when you're taking the same signals, and I'm going to take number 2 down, and we'll see what happens as we play with the response. Right now that's nothing is affecting the response, so this is the envelope as it's coming out of the ADSR. I'm playing with the attack. Now if we change the response, let's go halfway up, all the way off, halfway up, 3/4, all the way up. Now I didn't actually expect that. That's pretty neat. So if we contrast that with an unaffected second oscillator with a standard envelope, now we'll change that one's response, and it drops right off. You can see what it's doing to the input voltage levels. And again, the author emphasizes that this can be audio, it can be any voltage signal that you're affecting. So you could do this to an LFO, you could do lots of other things. I'm going to switch the trigger around. I'm going to switch the gate, and I had the sequencer running to the sequencer, and I'm going to change CV to the sequencer, and then we'll fire up the sequencer and listen. There we go. Now I'll change the responses. I'm going to speed this up, see how much it can handle tempo-wise. So that's what it does. It's very useful. Obviously, a mixer with a VCA in it is very valuable, and it sounds good, looks good. easy to use. It's a little wide, but you know, with these 5 knobs, it's hard not to be wide. So that's the VCA mixer from AI Synthesis. Hope you enjoyed the video.